This graph below shows a region bounded between y equals 5 minus root x and y equals negative 5 plus root x. So that means this function up here, this top curve, is y equals 5 minus root x. And this bottom one is, here, I'll change the color if that helps, is negative 5 plus root x. So, okay, I know because this is a positive root x function going up. This is a negative root x function going down. And see how it hits up at 5, it looks like. And this one hits down at negative 5. Okay, so there it is. And we want to take this region right here, this green shaded region, that region bounded, okay? So region is the base. It's the base of a solid object. If you slice straight down through this object, perpendicular to the base and parallel to the y-axis, the cross sections are all squares. Complete the integral for the volume of the solid object. Now that sounds confusing, so I want to show you a picture. In fact, let's go right here. There we go. So there is a picture of the shape. And let me do this to help. Make that a little bigger for you. And let's see that moving? There we go. That's going to be how we slice. Those are the slices that are, see how those are parallel to the y-axis, going along the x-axis? And each of those is a square. Now I know this, for some reason, this program, I mean, this is Desmos here. Those squares look taller than they are wide, but they're not. I know it looks that way from our perspective, but imagine they're squares. Remember, so in other words, their height is the same as their width. That's what a square means, right? Length and width are the same. So even though it doesn't look like those squares are taller than they are wide, it's just our perspective. So those are all squares. So see that three-dimensional shape that's created? We want to find the volume of that three-dimensional shape using those slices. Okay, so let's go to it. So here's a picture of it. I've written a couple things on it. So we want to figure out the volume. So here's this base region on the flat region on the ground. That's this right here. Okay, so here's the two curves coming in. So this top function is this one up here, 5 minus root x. Put that one up there. Y equals 5 minus root x. And the bottom one is y equals negative 5 plus root x. Okay, so how are we going to find the volume of this three-dimensional shape? That's what we're being asked to do. Find the volume of that three-dimensional shape. How are we going to do that? Right? The volume. Want to find the volume. It's the first time we've done volume. Well, the volume, we're going to basically need to add up each of these little boxes. How do you find the volume of one of those boxes? Well, their thickness is dx. Let me put that in there. So dx is the thickness of each of those going along the x-axis right here. Dx is the thickness. This is the width. And remember, the height is the same, even though it looks like that height is taller. It's a square, so it's the same. It's just our perspective. So what is the width? How do you find this width right here? Well, I've written in the width, it goes from the top function, the red one, down to the bottom function, the blue one. So the width is top function minus bottom function. So the width is going to be the top function, which is the 5 minus root x, minus the bottom function, which is negative 5 plus root x. Right? There's the top function up here, top function. There's the bottom function here, bottom function. So the width of this bottom side of that rectangle. So every slice, as we're slicing through there, each slice, the width is top function minus bottom function. That's how to find the distance between 2 points. You take the top one minus the bottom one. The top one is this function, the bottom one is that function. Subtract them, and you get the width. And then where do we go from there? So then area, the area of the square is going to be the height times the width, of course, right? So what's the height and what the width? Well, they're the same. It's going to be the same thing twice. Well, yeah, you know what? I should have figured it before I do that. Let me finish up the width work here. So the width will be 5 minus root x. Distribute that minus sign. Plus 5 minus root x. So it's going to be 5 and 5, 10 minus root x, that's minus 1 root x, minus 1 more root x is minus 2 root x. So it's 10 minus 2 root x. That's the width. And then the area of the square is height times width. And the height and the width are the same because that's what it means to be a square. So it's going to be 10 minus 2 root x times 10 minus 2 root x. The height and the width are the same. So that's better known as 10 minus 2 root x squared. That's the area of the square. That's not quite the volume. Remember, area is flat, two-dimensional. That's the area of the square right here. But then he has a thickness dx. So final step, as we'd say, the volume of each slice is going to be that 10 minus 2 root x squared times dx. That's the thickness, right? That's the area times the thickness. Area times, so we got the area of the square times how thick it is to get a three-dimensional volume of each slice. There it is. So then we just have to add those up. We just have to integrate those from 5 to 8. You can see right here, it starts at 5, goes to 8, right? In the original picture, we're going from 5 to 8. We're going to take the integral from 5 to 8. We're going to add up these volumes. 10 minus 2 root x squared dx. And there we go. There's the setup. We're not going to actually compute the answer. We're just going to stop right there. You know how to do integrals. You could do that with a u sub. Or actually, maybe that one might be a tricky one. I mean, whatever. We could definitely do it. But we'll just leave it be. We just want to practice the setup. So there we go. That's how we would do that one. And that goes back to the original question. They wrote the format a little bit differently, but it's another way of saying the same thing. So ours is the same as theirs. And there we go. That's the volume of the three-dimensional shape.